Alright, so we are doing 8G today. So that's we're going to be looking at the recurrence relation for a geometric sequence. So that's the rule that we can use to generate a geometric sequence. And also we are going to look at how to calculate or find the nth term of a geometric sequence. So just a reminder, a geometric sequence is a sequence that have a common ratio. So you take any number in your term or in your sequence. So if I pick 12 and I divide it by the previous term, I get 2. And if I pick 24 and I divide it by the previous term, which is 12, I also get 2. So the common ratio R is equal to 2. So that's a geometric sequence. So here we have the recurrence relation for a geometric sequence. So in order to generate a geometric sequence, we need to know what the first number is so that we can use the first number to generate the next number and the number afterwards. So T1, so the recurrence relation has consists of T1, and it consists of a rule to generate the next number in the sequence. So T1, which is, so we look at the example above here, which is 3, 6, 12, and 24. Okay, so T1 for our sequence above would be 3, right? And then Tn plus 1, so T of n plus 1 equals to R. R is 2, we just worked that out. Okay, and then T of n. So if you want to write the recurrence relation for a geometric sequence, there is just 2 things that you need to know. Okay, the first thing is T1 equals to A, right? And the second thing you need to know is the ratio, the common ratio. Okay, and once you know what they are, just substitute it into here and here, and we get a geometric sequence. All right, so the next formula we are going to look at is this formula over here. And this formula allows us to find the nth term or any number in the any term in the geometric sequence. Okay, so Tn, so Tn equals A, again, A is the first term, and R is the common ratio, and n minus 1. So that's the formula. And we're going to use this in a minute. All right, so let's look at the first example. Okay, so we've got a recurrence relation here. So we can use this to generate the sequence, right? So generate and graph the first 5 terms of the sequence defined by the recurrence relation. So we need to generate 5 terms. So we're told that the first term is 5. So we're going to start at 5. So we'll go 5. And this part here says the next term is equal to 2 times the current term. So that just means we need to multiply 5 by 2 to get to 10. And then we're going to multiply 10 by 2 to get to 20, and so on. So now we have the first 5 terms. Okay. So use a rule to calculate the 10th term. So we are going to be using this formula up here at the top. So this formula here. So we want to find T10. So we'll go T10 equals to 2 times, A, which is 2, yep, times R, A is 5, my bad, A is 5. So A is 5, A is the first term, A is 5. So it will be 5 times R, so that's A and that's R is 2, times 10 minus 1. So just substituting the value 10 into where n is. So now we can simplify and evaluate. So 5 times 10, so 2 to the power of 9. And I think 2 to the power of 10 is 1024. So 2 to the power of 9 is 512. So T10 equals to 5 times 512. And I'm going to 512. I don't know what that is. I'm going to have to use my calculator. Actually, we can do that in here. So 5 times 500, that's 2500. And that's think that's, no, it's 2500. And 5 times 12 is 60. So I think it's 2560. So 2560. 2560 should be our answer. If I made a mistake, let me know. All right. So that's that. Now we can graph this, and just a reminder, when we're graphing a geometric sequence, we get a curved graph, not a straight graph. So when you graph it, it'll look something like that. Okay, so T1, that's we started off with 5. So T1 is 5, T2 is 10, and is doubling each time. Okay. All right. So if you got questions, just put them in the chat. I'll answer the questions. Otherwise, we'll move on. So let's look at the next example. So we're going to look at example 19. All right, so example 19. So for cube number 1, the volume is 8 centimeters cube. So 8 centimeters cube. All right. And it tells us that the volume of each successive cube is 1.5 times the volume of the previous cube. Okay, so that just means that if we want to find the volume of cube number 2, we need to take 8 here and multiply that by 1.5. Okay, so 8 times 1.5, that's 12 centimeters cube. And we want to find the volume of cube number 3, we multiply 12 by 1.5 again, and that should be 18. Okay. So here we're given our recurrence relation. So that's just saying the first term is 8, right? The next term is equal to 1.5 times the current term. Okay, so use this recurrence relation to generate the first 4 cubes. So we've already did for the first 3 cubes. So let's do that for the next one, the first 4. So cube 4. So again, we're just timesing the previous term by 1.5 to get to the next term. Okay, so 18 times 1.5. So half of 18 is 9, so that should be 27. So this here should be 27 centimeters cube. So, okay, so 18 times 1.5 should give us 27. All right, so we've generated the first 4 terms. So they are 8, 12, 18, and 27. And again, if you want to find cube 5, just multiply 27 by 1.5. That'll give you the first 5 terms. Okay. So now we're going to have to plot the graph. All right. So I'm just going to do this roughly for you guys. So, this here would be 1, 2, 3, 4, and 5. This is cube number. And this is volume. Okay. So I'll probably break it up into tens because we only go up to 30. So we're only going up to cube number 4, which is 30. So I'm going to break it up into tens. Well, that should be 20s. 20 and 30. All right, so I'm just drawing out dot plot. So cube number 1 has a volume of 8, so it's about there. Cube number 2 has a volume of 12, roughly there. 3 would be 18, and 4 is 27. So it looks like a straight line, but again, when we're plotting a geometric sequence, we get a curved line. So that's our graph for part B. And we're going to look at part C now. So again, it's asking us to use the rule to calculate the nth term. So just a reminder that that's this thing here, up here. Okay, so this is the formula for calculating the nth term. So Tn equals a r to the n minus 1. So I'm just going to write that down again over here. So Tn equals to a r to the power of n minus 1. All right, so Okay, so now we want to find T10. It's asking us to predict the volume of the 10th cube in this sequence. Well, a bit hard to predict, but let's give it a shot. So we'll go T10 equals to A. Well, A is the first term, isn't it? So what's the first term in our sequence? The first term is equal to 8. So I'll put 8 here. Then times R. R is 1.5 to the power of 10. Okay, and 1.5 to the power of 10, geez, you're multiplying 1.5 by itself 10 times. I'm not going to do it. I'm going to bring up my calculator and cheat my way through this one. So let me bring up my calculator. So 1.5 to the power of 10. So 1.5 to the power of 10 is 57.67 roughly. 665. So it would be 8 times 57.665. I'm going to double check that. All right, 57.665, and we're going to multiply that by 8. All right, that's 461.32. So T10 equals to 400, and it's bad memories today, 61.32. 461.32. Okay, I wouldn't have predicted that, but yeah, that's it for today's video. Let me know if you need any help, and I'll get back to you.